To Thursday Defensive, put on by Recon InfoSec. We are here today just as a bunch of nerdy cyber people talking about defensive topics. Today we've got Mr. David Chang. Now, there's a phrase, or Chow, sorry. There's a phrase we use often in where we say, this person wrote the book on the subject. Yeah, so David is here to talk about detection engineering and detection engineering automation, and he did in fact write the book on the subject. So Dennis, sorry. Why did I think Dennis? I apologize, sir. Mm, clearly not enough coffee this morning. It does a little bit. It's been a long week already. Well, tell us a little bit about your background and what you've been up to besides writing awesome books. That's pretty awesome. I didn't know you were doing the training and mentorship. That's very cool. That's very cool. So what obviously we do a lot of detection engineering here at Recon. We have kind of a pipeline that we've built over time, but tell me about your recommendations and kind of what you like to cover like from the ground up building your CI/CD.
So if I can jump in, so this is one of my favorite topics, Dennis. So I love this. But I want to bring it back down to kind of a level that maybe everyone could resonate with, because for someone who's pretty far along in this journey, like a lot of the stuff you're saying right now is like, oh yeah, totally, absolutely, it makes perfect sense. To someone who's like, say, just diving into their first seam, and there's going to be a bunch of rules that are probably already in there from the vendor, and they're just starting to wrap their head around like tuning detection rules and stuff like that, right? Generally, in my experience, the evolution of that is you first start with the product itself, right? So say I'm using Splunk, and it's got a bunch of security rules built into it. Naturally, the first place I think to tune and tweak and modify those rules is inside Splunk. That's where these rules live, right? But what you'll soon find out is there's a lot of shortcomings with that approach, right? Splunk's not keeping track of versions of all those rules over time. It's not running tests on those rules, right? So if I go in and tweak a rule because maybe I'm tuning out a false positive, how do I know that the tweak I'm making to that rule didn't just completely neuter or break the rule altogether, right? And so one of the things that I've seen that I was a huge fan of, there's a company called Soteria. It's an MDR company on the East Coast, and they've got a really cool detection engineering approach where they wrote a VS Code extension and said, "Hey, look, all of our rules that we work on, we do it in VS Code, and we have our own VS Code extension that would allow us to run unit tests against each rule." Now, this isn't quite at the level of automation of CI/CD magic. That's the ultimate goal. But at the very least, give me a development environment where, as I'm tweaking my rule, I can have two or three or four different example telemetry items that rule then gets tested against. So I'll have like two true positive samples that it should always fire on these. And then I'll have maybe two false positive samples that it should never fire on these, right? And that way, as the analyst is tweaking and tuning the rule, they run those unit tests, make sure they get all green lights, and it's like, okay, this rule is probably good, right? But keep in mind that the trade-off there is the test, or the output of the test is only as good as the test itself, right? So if we have very limited telemetry samples to test against, then you have very limited coverage there. But the other important consideration is, as I'm tweaking and tuning that rule or crafting a brand new rule, is making sure that we're doing some due diligence on what would the false positive prevalence be of this new rule or this now modified rule. Can we run it against historical data set and then identify, okay, if this rule existed 6 months ago, how many false positives would it have created, right? And then having a threshold, like internally, like we do not commit a rule to prod that generates more than X% of false positives, right? Like, and zero is not always the right answer, because it's like, well, this rule is a really, really good rule, but once every 3 or 4 weeks, it kicks out a false positive. Okay, maybe that's just the cost of doing business. If it is a really good rule, then maybe we navigate the false positive rate if it's an acceptable one. But having a test bed that would take a new rule, run it over historical data, and then generate that output of, hey, this would have kicked out 15,000 alerts in the last 6 months, which means it's going to probably kick out 15,000 alerts over the next 6 months, right? So let's continue tweaking and tuning before this thing goes into prod. And then I think to Dennis's point, the ultimate goal is you automate all of this. You automate the unit tests and you automate the historical analysis. But part of the evolution is, can you even do these things manually today, right? How would you manually do that? Because that's what kind of defines, I guess, the automation opportunities. And so just kind of make sure you're working with tools that allow you to do these things.
Dennis, I'm curious, just on this topic of manual versus automated, because you started with, get set up in GitHub. In your experience, do you ever do manual reviews in GitHub for, a human reviewer for a PR or anything like that? Okay, cool. Question from the chat. Justin asks, when would you say an org's ready to maturity-wise to adopt detection as code? Very cool. Makes sense. Um, I lost where I was going to go. Now it happens to us all. So you have a fairly involved process when it comes to that manual approval, really. Do you find or have you found that like new 0 day drops this morning and we need to get detections out? Do you circumvent that or do you have some kind of alternative process or do you just kind of try to push through a little faster? Dennis, I love this idea of like automatically expiring a rule out. How have you seen that instrumented? How have you actually like what's the automation around that to do that? Awesome. Um, that's yeah, no, that's an incredible idea. I just hadn't really thought about auto expiring them out. I think that that's fantastic. What are some of the things that you feel like, and then I've got a question from the chat as well. Uh, what are some of those rule performance metrics in your mind? Obviously, false positive rate and things like that, but what are some of the others that really trigger you as, okay, this rule is very good or this rule is very bad? Sure. Right. No, that makes a lot of sense. Because I don't want to miss it before we run out of time, Dennis. Watson asked, how do you integrate open, or how often do you integrate open source detections like Yara and Sigma and things like that? So and I know you spoke to it a little bit, but Justin asked more specifically, what kind of fidelity do you see from the open source ones? How much tweaking and tuning really happens there? Okay. Cool. All right. Well, we are almost at the top of the hour, so it's probably time for our family picture. Anybody who wants to turn their camera on real quick, we can do that. And Dennis, this has been fantastic. This is probably one of the best talks I've been a part of. Thank you so much. Absolutely. And if you wanna come back and chat with us at any point, by all means, let us know. Yeah, absolutely. Outstanding. Look forward to it. Is there anything else that you want to talk about, or anything that you want to let anybody know where to find you or how to get a hold of you? Awesome. Well, Dennis, again, thank you very much. This has been a great conversation. Definitely appreciated it. Dennis Chow, have a great afternoon. I'm going to do our picture real quick here. Three, two, one. Boom. All right. All right. Well, that's the top of the hour, everybody. Thank you again. We will be here next week. Have a great afternoon. See you.